So we're starting our last unit in Math 143 and Math 043 for the correct class. I have here a preview of simple and compound interest. If you need any calculator help, I'll speak a little bit about calculator in these videos for Math 043, but there is a specific video in your Math 143 class at the top of the coursework in the notes section for Unit 4 that talks about the calculator and that sort of thing. So be sure you reference that. And you can always send me a screenshot of your calculator and I can help you troubleshoot how to enter it into your calculator as well. All right, so with that said, this first example up here at the top really just talks a little bit about number sense and math financial sense. I should say that Unit 4 is all on consumer finances. So you're talking about buying and selling, buying a car, investing in your 401k, saving for the future, borrowing money, saving money, investing in the stock market. What else do we talk about? Buying a house. What would your house payment be? Those sorts of things. And also credit cards. So very useful topics. All right, so here in example 1, it says Aaliyah works at a mall and makes an average of $12.80 per month. Her rent's $425 and her car payment's $309. Her parents give her $200 per month to help her out with her expenses. Her cell phone bill is $115 and she usually spends about $200 a month on gas and food. Part A wants us to identify Aaliyah's total monthly income. So she's got a couple of income sources here, right? It says that she works and she gets and makes an average of $12.80 per month, but then it also tells us that her parents chip in and give her an additional $200 per month. So her total monthly income then would be that $12.80 plus the $200, and so her total monthly income then $14.80. In Part B, it says identify Aaliyah's total monthly expenses. So her expenses, she's got several of those. She's got her rent, $425, so I'll start writing these out. So she's got her rent at $425. She's got a car payment of $309, so we'll add $309 to that. She's got a cell phone bill of $115. And she usually has another $200 worth of food and gas expenses. So we add that up and we arrive at $1,049. Part C then asks, is her monthly cash flow positive or negative? So think about this. This is her income. This $1,480 is her income, and then the $1,049 are her expenses. Since her income is larger than her expenses, then her cash flow would be positive. If she was spending more than what was coming in, that would be a negative cash flow. Okay. In Part D, if Aaliyah needs to save $13.84 to pay her tuition next semester, how much should she save each of the next 4 months to reach that goal? So nothing fancy here. This is her goal, $13.84, and she's got to figure out how much to save each month, so you're going to divide that by 4. So $13.84 divided by 4 should get you to $346. So she would need to save an additional $346 a month to be able to pay her tuition. So Part E wants to know, will she be able to save for her tuition given her current income and spending habits? So we first need to figure out, well, what is her excess? We know her income is $1,480. Take out her current expenses of $1,049, and that leaves her with $431. So since she's going to have $431 left over and she needs $346 to save for tuition, then yes, she is going to be able to account for her income and her spending and still do that saving there. Okay. All right, so let's move on to simple interest. And again, that's really not part of the course here, but it ties in terms of thinking about money in, money out, and saving and that sort of thing. To get a little bit more targeted and specific to your course, though, first topic will be simple interest. Simple interest is paid at the beginning of a time period, and your interest, however, if you're saving money, you do not earn interest on your interest. You only get a one payout of interest. Or if you're borrowing the money, it's a one-time as well. All right, so simple interest formula, I equals PRT. You do have here in Unit 4 a formula sheet, so be sure that you reference that. Your simple interest formula equals PRT, and then your accumulated balance formula is just underneath that. A stands for the accumulated balance, your final amount, equals principal plus interest. I just stands for interest, P is your principal. Principal is how much money you put into your account. R is your interest rate, always has to go in as a decimal. T is your measured time in years, and that accumulated balance is the final amount in your account. Time, again, is always measured in years. If you're, for example, if you were ever said, okay, well, I'm going to save for, let's say, 7 months. If you want to convert months to years, since time always has to be in years, then you're going to put months over 12, so it'll be 7 divided by 12. If you're given days, say you want to, I want to contribute for 200 days, then I would put 200 over 365. I just put a little disclaimer. A lot of times banks will just use 360 as a nice even round number as opposed to 365. Because as we know, some years have 365, some have 366. It's a negligible difference, really. Usually it's pennies. All right, so here in example 2, Jenny borrows $700 at a 7.5% interest rate for 2 years. First part here says use the simple interest formula to figure out how much interest you would pay in those 2 years. So your interest formula, I equals PRT. She's borrowing, so 700. Your interest rate, put it in as a decimal, 0.075. And then your time, 2 years. Your time's already in years, so you just put it in as 2. You just put that in your calculator. $105 would be what she would owe. So then the next part says, well, what's the total amount then she'd have to pay back? She's going to have to pay back then the $700 that she borrowed plus the $105 in interest to give you a grand total here of $805. Okay. Let's look at example 3. It's very similar. The only difference here is the time units. So here it says that Blake is investing $4,725 into an account with an annual simple interest rate of 2.57% for a time period here of 3 years, 8 months. Okay. The first part here says, what value would we use for T in the simple interest formula? Remember, T has to be in years. So the 3 years is good, but we need to convert this 8 months into years. You can do it, and I should say you can do it that way, but what I actually find is let's convert all of it to months, to that lowest unit, and then convert months to years. So here's what I mean by that. 3 years is equivalent to how many months? 3 times 12, so that would be 36 months. Add to that additional 8 months. So 36 months plus 8 months, we're looking at, what, 44 months? And then I would check, so they take that 44 months, and to convert it to a year, you put it over 12. And so I would just keep it at 44 over 12. I wouldn't bother trying to reduce it. I would just keep it at 44 over 12. All right. So that's what would always be my recommendation when you have a, if it was 6 months, 6 months is half a year, so you could do 3.5. But in 8 months, I think is actually not a bad decimal either. 8 divided by 12. Actually, it is. 8 divided by 12 is 0.67, and you definitely don't want to round. So, what I always, and I even do this in the 143 video on this section as well. I always tell you, look at that smallest unit, convert the larger unit to the same unit, and then convert to years. Okay, and you convert months to years by dividing by 12. Below that, how much interest will he earn at the end of the term? So just use your interest formula. I equals PRT. So 47.25. Your rate, 0.0257, and then that time, 44 over 12. You can put that all in your calculator at one time, nothing fancy. When you get over here to this 44 divided by 12, you can simply type in 47.25 times 0.0257 times 44 divided by 12. You don't need a fancy fraction button. When you do that, you should arrive at $445.25. And then the second part over here, what's the total account value at the end of the term? So the total amount would be that accumulated balance, principal plus interest. How much did you put into the account in the beginning? 47.25 plus how much it earned for you. We just found 445.25. When you add that together, you should arrive at 5170.25. All right, we'll flip it on over then. Top of the next page, I will let you try example 4 and 5, very similar to what we were just doing in those previous two examples, but that gives you a little bit more practice with that. So let's move on then to compound interest. With compound interest, you are earning interest on your interest, so it's very advantageous to have a scenario with compound interest. The formula here is over here on the left, A equals P parentheses 1 plus R over N raised to the N times T. A still stands for the final amount in the account. P is the starting amount in the account. R is your interest rate. T is still time in years. N is the number of times that it's compounded in a year. Possibilities for N are over here on the table on the right. So if you compounded it annually, then you're only going to get one payout. A semi-annually, you're going to get two payouts. Quarterly, 4. Monthly, 12. Daily, 365. Okay, so you need to know those. Let's do example 6 together. Cindy invests $1,000 in an account that earns 4% interest compounded monthly. Cindy wants to calculate how much money will be in the account in 5 years. Once you see the word compounded, that tells you that you're going to a compound interest formula. And so when I see that, I automatically then write out what I have here in the notes for you. A, P, R, N, and T, and I fill in what they gave me. It said that she invested $1,000, so that's the starting amount. That's my P. That's how much she put in. So I'm going to put $1,000 here. Your interest rate, 4%, so let's go ahead and put that in as our decimal, 0.04. Compounded monthly, so my N is 12. T, we want to figure out the account balance in 5 years. Since I'm missing my A, I'm using the A formula. And so it would look like this, 1,000 parentheses 1 plus your rate, 0.04 divided by 12, raise it to the parentheses 12 times 5. Every parenthesis that you see here on the formula sheet in your notes, you need to put those parentheses in your calculator. Do this all at one time. Most calculators can handle it, and you won't do any rounding until the very end, and we're talking about money in this class, so you're doing dollars and cents. When you do this problem, you arrive at 1220.996. And I purposely wrote this out because what happens here, since you're doing dollars and cents, this 6 back here is rounding up that 99 cents to a full dollar. So final answer here would be 1221. Okay? That at the end of that 5 years, that $1,000 has grown to 1221. Okay, is essentially what's happening here. All right. I will let you do example 7. I think my solution key has shown you the steps for that. And let's flip it on over then to the next page. This page, or the next formula, is just a manipulation of the previous formula. Your previous formula for compound interest is solving for the final amount in the account. But let's say, for example, you have in mind that you're trying to plan for the future, and you are trying to maybe save up money to put down payment on a house, and you want to have $20,000 to put on that house. Then you're trying to figure out, well, how much do you need to put away now to reach that end goal? You know your final amount of $20,000. Or maybe you want to plan for something smaller. You just want to plan for a trip in a couple of years, for example. And so you have an end goal of, oh, I need $5,000 for this trip. How much do I need to be putting away now to reach that? It could be also saving for retirement, saving for your kids' education. So I always think of when your problem starts talking about planning for how much would you need now to reach this end goal, this is the formula that you're going to be using. So let's look at example 8 together. In example 8, it says, how much money should Bob invest today to have $35,000 in 12 years, 7 months? Assume that the money earns interest at 6.5% compounded semi-annually. Again, I see that compounded word, so I know that I'm going to use one of those compounded formulas. Here, it wants to know, though, how much should he invest today? I'm trying to figure out that p-value, but we know that he wants to have an end goal, a final amount of $35,000. So that's my A value, final amount. Your interest rate, 0.065. It is going to be compounded semi-annually, so my N is 2. My time, I'm going to have to do a little bit of work here. 12 years, 7 months. I need to get all of this into one unit. I need it all in years. So let's convert it all to months first. So 12 years, convert that to months. So 12 times 12 is 144 months, plus the 7 gives us 151 months. Convert that 151 months to years by putting it over 12. Okay, we are solving for P here. We don't know how much. We're trying to figure out how much do we put in now to reach this 35,000. So we're missing our P, so we use our P formula. P equals that 35,000. Let me make my pen a little smaller. Divided by, and in your calculator you would 35,000 divided by, start a parenthesis, 1 plus your rate, 0.065, divided by your n is 2, close it, raise it, start another parenthesis to the n, 2 times t, 151 divided by 12, close parentheses, and then you would hit enter or equals in your calculator. You really should be able to do all of that in your calculator all at one time, again, utilizing these parentheses. If you have to do it in steps, then you need to do the bottom first and take it out a minimum of 5 decimal places. Don't round it to just 2 decimal places. If you start doing this intermediate rounding, you're going to create error and your numbers are going to be further away from the true exact answer. Think about it, you wouldn't want the bank to do that to you. Especially if it was money that you owed them. All right, so so then after you put that in your calculator, you should arrive at 15,649.54. Okay. Example 9 is exactly like that one, so let's try that. Now at the bottom, all that I've done is I have just given you some extra practice for working with simple and compound interest formulas. So once you see the word simple interest, then you just have your I equals PRT. But when you see that word compounded, I highly recommend just go for yourself and write down an A, P, R, N, and T. And then you're either going to be missing A or P. If you're missing A, use the A formula. If you're missing P, use the P formula. Okay? All right, so always reach out if you have any questions with these formulas or putting it in your calculator. Let me know. Thanks a lot. Bye.